Hello everyone, I'm Ishwar Prasad Sridhar, a PhD student from the Department of IMSc at UT Arlington. Today, I'll be explaining our research project evaluating depth perception in robotic teleoperation. My co-author Vibhav Nirmal and I worked on this project under the guidance of our advisor Dr. Mahamudur Rahman. We compared traditional monoscopic displays to a 360-degree immersive stereoscopic system to assess whether it improves depth perception in remote robotic teleoperation. Executive summary. In our study, 29 participants used a Viper X300 robotic arm, a 6DOF arm controlled via a joystick to perform pick and place tasks. They experienced two visual conditions: a standard 50-inch TV providing a monoscopic single camera view, and a MetaQuest 2 VR headset displaying a 360-degree immersive stereoscopic feed. Our system used a six camera view stitched together to deliver true stereoscopic vision, which significantly enhanced depth perception. Overall, stereoscopic setup improved task completion times by 26%, reduced perception errors by 25%, and also lowered cognitive workload. Background. Traditional teleoperation relies on monoscopic vision, where a single camera view is displayed on a flat screen. This method lacks the depth use our brain uses to judge distances accurately, leading to higher cognitive load and slower, less precise performance. In contrast, stereoscopic vision uses two different camera angles to create a three-dimensional effect. Our approach goes a step further by combining a six camera view to form an immersive 360-degree stereoscopic image, offering operators a more realistic and detailed perception of the environment. This enhanced depth perception is crucial for tasks in high risk fields such as bomb disposal, nuclear waste handling, cave exploration, and space missions. Experimental setup and test plan. For our experiment, participants controlled the robotic arm using a joystick to perform a series of pick and place tasks with objects of various shapes and sizes. In the monoscopic condition, a 50-inch TV displayed a single camera view, while in the stereoscopic condition, a MetaQuest 2 VR headset showed an immersive 360-degree feed from the Insta360 Pro 2 camera, which stitches together the six camera views to create a true stereoscopic vision. A student researcher recorded key metrics such as task completion time and perception errors. Participants also completed a NASA TLX survey and user perception survey to measure cognitive workload. We used a within subjects design to minimize variability. To reduce learning effects, tasks were divided into randomized blocks with the order of object selection randomized for each trial. Before the experiment, participants completed a pre screening survey. Upon arrival, were briefed on the study, provided informed consent, and filled out a demographic questionnaire. Then they underwent a training session with the robotic arm to familiarize themselves with the controls before proceeding to the randomized task blocks. After the first task block, participants took a 10-minute break before continuing on to the second block. Figure 3 shows our streaming architecture, which was designed to address slow latency, a critical factor in teleoperation. The Insta360 Pro 2 transmitted its video feed via RTMP to an Ant Media server hosted on Linode Cloud instance, which then converted the stream to WebRTC. This setup achieved a latency of about 1.2 seconds and supports multi-user connections, enabling several viewers to access the stream simultaneously. Figure 4 illustrates our experimental setup. Part A shows the Viper X300 robotic arm in action with the MetaQuest 2 and the joystick used in our study. Part B captures a snapshot of the participant's training session. Part C shows us the operator's point of view during a task. Part D presents us the objects used in the experiments. In part E and F, we have a participant performing the task through a monoscopic setup on a TV and a stereoscopic setup on a VR headset. Experimental results. Our results showed statistically significant improvement with stereoscopic vision. Participants completed tasks about 26% faster, averaging around 115 seconds per task compared to the 150 seconds with monoscopic displays. Additionally, the stereoscopic setup reduced perception errors by approximately 25%, with operators making two fewer errors per task. We also observed that object complexity significantly affected performance. Irregular objects like action figure and hammer led to longer task completion times and more errors than cubes and balls. Moreover, participants with prior VR experience performed better in error reduction, while VR joystick experience did not significantly impact the results. Finally, the NASA TLX scores confirmed that stereoscopic vision reduced overall cognitive workload during teleoperation. In conclusion, our research shows that immersive 360-degree stereoscopic vision does dramatically improve depth perception in robotic teleoperation. This approach speeds up task completion and reduces error, lessening cognitive workload on the operator and making remote manipulation more efficient and safer. We are currently integrating the system onto a mobile robotic platform for future work to facilitate real time remote exploration in challenging environments like caves. Here are some references. Thank you. I'm looking forward to seeing you all on April 15th and answer any questions you might have.